Morning everyone, welcome to my YouTube channel. So here today we are going to be looking at the vector product. So the vector product is also known as the cross product. So when you cross two vectors, or when you multiply, let's say, two vectors, when you cross two vectors, let's say you have vector A and vector B. So if you cross these vectors, or if you find the vector product, so the vector product means A cross B, like that. So A cross B will always give you, let's say, a vector which we are going to call C. This vector is perpendicular to both A and B. For example, we have, let's say we have three vectors. We have our A, let's say it is here. So let's say we have our A here. We also have our vector B here. We have our vector B here. Now, in order for you, let's say you have another vector now, which we are going to be calling C. Let's use a different color. So your vector C, which is starting at this point, moving like that. So this vector will be perpendicular to both A and B. So the angle between C and B will be 90 degrees. Even the angle between A and B. So this vector is perpendicular to both A and B. So that's why when you want to verify your answer, you can say A dot C should be equal to, if you find the cross product, should be equal to 0, because these two vectors are perpendicular. If you see A dot C, you know that the dot product between two vectors is equal to 0. Even the dot product between C dot B, because the angle between them is 90 degrees, even the dot product there will be equal to 0. So you can just use that to verify. So let us know how to cross two vectors. Let's say this is what you have. So how do you cross two vectors? Let's say A cross of B. So A cross B should be equal to, you do this. So this is your A cross B. So what you're going to do is these letters I, J, and K, you will put them on top. So you will have your I, then you will have your J here, then you will have your K. Then get the coefficients. So here we have, for I we have a 2, for J we have a 3, for K we have a 4. Then we are going to have, here we are going to have a 1, since this is 1, the coefficient here, the coefficient is -1. So we put -1, then our K is 1, like that. So this is our vector. This is our vector. Now how do we cross them? So we are going to be using this method. So to cross two vectors, it is similar to the matrix method, which should be equal to. So what we are going to do is, we are going to do this. Look at the first row. So the first column. So the first column, we have we are going to do this. We are going to draw dotted lines. So the first column, then this one will just be up here. So now you will ask yourself, where do they meet? Now the way the matrix determinant method works is that first you use the positive, second you use the negative, then you use the positive. If you want it's negative, positive, negative, but this one, let's just go with the one positive, negative, positive. So what we are going to do is, after doing that, we are going to look at where do they meet. So these two lines where I've drawn, they meet at I. So you are going to write, since we are going to begin with a positive, so it will be positive I. Then you are going to write, what numbers am I remaining with? So the numbers that you're remaining with are just 3, 4, -1, and 1. So you're going to write your 3, 4, -1, and 1. Then you move to negative, which is here. Then what you're going to do is go for your second column. So we are going to our second column. So you are going to do the same. So second column, do that, but on top you are going to be doing that. Now where do they meet? They meet at J. then write the numbers that are remaining. So the numbers that are remaining are 2, 4, 1, and 1. So these are the ones that are not shaded, or more like not crossed. Then we are going to have plus. We are going to look at our last column like that. So to get the final value, we are going to look at our last column, do this, then also we have that. So now we are going to pick these two lines meet at K. So we are going to write K. Then what are we remaining with? We have a 2, 3, 1, -1 like that. So immediately we have done this, it means to say we have done the needful. So now from here, we are just going to be more like finding the determinant. So how do we find the determinant? You multiply the major diagonal, then subtract the minor diagonal, which is this one. So now, with that said, we can now be able to just do as though we are doing determinant. So our determinant is A cross B should be equal to, we have our I, then we are going to have this one, it will be 3 times 1. So we can write our 3 times 1. So we multiply this, then subtract our -1 times 4. So that's how we find the determinant. Then we are going to do the same for -j. Then we are going to have our 2 times 1. So this 2 times 1. Then minus our 1 times 4 like that. Then after doing that, we can be able to add plus. We have our K. Then we are going to open brackets. Also do the same. We have our 2 times this -1 like that. Then we subtract 1 times 3. So we have 1 times 3 like that. So after doing that, we can be able to simplify things. So we have our I, which should be, we have our 3 times 1, which is our 3, minus our -1 times 4, it is equal to -4 like that. Then we have our -j like that. Then we have our 2 times 1, it is equal to 2. Then our minus 1 times 4 is 4 like that. Then we have plus our K. For our K we have, so we have our K like that. Then we have our 2 times -1, it will be -2 like that. Then we have minus our 1 times 3 is equal to 3 like that. Then after doing that, we can be able to simplify things. So this will be our I. Then in brackets we have our 3. Negative times negative, it will be +4. Then we have minus j. Then we are going to have a 2 minus 4. It gives us -2. Then we have plus k. Then finally we have -2 minus 3. It will give us -5 like that. Then we are going to add. So we have our I. 3 plus 4 gives us a +7. Then we have minus our j. Then we have our -2 like that. Then we have our plus k. We are going to simplify it at the end. So now let's multiply. So our 7 times I, it will be 7i. Then our -2 times j, it will be plus 2j. Then we have -5 times k, it will be -5k like that. So this is how we find our A cross of B. So this is what we have as our answer. Now let's say they have asked you to find the angle. We are going to solve another one. So let's say they have asked you to find an angle, saying, so when they say the sine of the angle between these vectors, so immediately sine, they want you to use the trigonometric ratio, which is our sine. So the cross product is connected by the following. So we have A cross B should be equal to the magnitude of A times the magnitude of our B. Then we have the times the sine of theta. So meaning to say, for the cross products we use the sine, for the dot products we use the cos, like that. So now after doing that, we know what it should be the magnitude of this. should be equal to the magnitude of that. So now we know what our A cross B is equal to. So A cross B is equal to, we have our 7i like that, then we have plus our 2j like that, then finally we have our 2j like that, then we have minus our 5k like that. Then our A, we know that our A is equal to, so this is our A and this one is our B. So what we are going to do is, in order for us to find the value of this, we can be able to say, so we can be able to say, first let's find the magnitude. So this means magnitude, meaning size. So we can be able to say our size of A cross of B, just the size, should be equal to the square root of our x squared plus our y squared plus our z squared, which should be equal to the square root of our x squared. So in this case, for A cross B, we are going to have our A cross B, we are going to have this value. So A cross B has got values such as x is equal to 7, the one with I. So you can watch my video on magnitude in case you do not know how we are doing things. So it will be 7 squared plus our 2 squared. For the one with j is the one for y. Then we have plus our negative 5 squared like that. So after doing this, we can have the square root of 7 squared gives us a 49, plus 2 squared will give us a 4, plus negative 5 squared will give us 5 like that. So when we add these, we are getting, so 49 plus 4 plus 25 gives us the square root of 78 like that. So we have A cross B, this is the magnitude, or rather the size. So we can replace it when we are done. So getting these, now finding the magnitude of these, we are going to get, so in order to do this, we are going to say the magnitude of our A, this one gives us the magnitude of our A should be equal to square root of our x squared plus y squared plus z squared. So which should be equal to the square root of our x squared is 2 squared plus our y squared is 3 squared plus our z is equal to 4 squared. So we are going to have the square root of 2 squared is 4 plus 3 squared is 9 plus 4 squared is 16 like that. So when we add these, we are getting, so the magnitude of A gives us the square root of 29, because when we add 4 plus 9 plus 16, it's giving us 29. So finding the magnitude of B, same approach, should be equal to the square root of x squared plus y squared plus z squared like that, which should be equal to our x, the coefficients are, we just get the coefficients, we have 1 squared plus 1 squared plus 1 squared like that. So 1 squared, 1 is negative, it won't change anything. So we have the negative there, so we can put our negative 1 squared plus the 1 for k is positive, so we have that. So we are going to have 1 squared is 1 plus negative 1 squared is 1 plus 1 squared is 1. So we can add 1 plus 1 plus 1, which will be equal to the square root of 3 like that. So after doing this, we can now be able to find the sine, that they have given us the sine of the angle between these vectors. So we can say A cross of P like this should be equal to A, magnitude of A times the magnitude of P times the sine of theta like that. So after doing this, we can be able to say A cross B, we have found a value which was equal to the square root of 78, should be equal to the magnitude of A, which is equal to the magnitude of A, we found this, the magnitude of B, we found this. So it will be the square root of our 29, then the magnitude of our B will be equal to the square root of 3 like that. Then we have the sine of theta. As we know, the radicals can multiply themselves, so we have the square root of 78 should be equal to 29 times 3. This gives us 29 times 3 gives us a value of the square root of 87. 3 times, we just multiply what is inside. 3 times 29 gives us 87. Then we have the sine of theta like that. So we divide this over the square root of 87 over the square root of 87. This gives us a value of, knowing that this will be our square root of 78 over the square root of 87 like that, which should be equal to the sine of theta. So let's, so they did not necessarily want the angle, they just wanted you to leave your answer in terms of sine. They said the sine of the angle, meaning to say sine theta should be equal to this. Now let's just reduce it a bit so we can be able to just combine the radicals the way they are. You can, if the root is the same, we have the square root, you can have just one big square root, 78 over 87, which should be equal to the sine of theta. Let's see how far we can reduce it. So to reduce this, we can divide our 78 divided by 3 gives us 26, and 78 divide 87 divided by 3 gives us 29. So the answer will be equal to the square root of our 26 over 29, which should be equal to the sine of theta like that. So this is how we find the sine angle of theta using the cross product. So let's attempt another one. So these are some of the questions that you expect under the cross product. So let's say they tell you the unit vector perpendicular to each vector. So this unit vector that is perpendicular to each vector, this means to say they are talking about the cross product. If we have, let's say we have our A like this, we have our B like this, then the vector that they are talking about is the cross product, which we are going to call our C, because this is the only vector that can be perpendicular to both A and B. Now we know that the unit vector is a vector of unit 1. So we know that our A cross B, so this C, when you just look at this C, in the actual sense, this C is your A cross of B. This is the vector that is perpendicular to both A and B. So if that's the case, the unit vector, you can watch a video on unit vectors. Unit vector is a vector of unit 1 or of magnitude 1. So now, what we are going to do is, the unit vector is defined as the unit vector, which we are going to call, since the A cross B should be equal to, we found A cross B to be equal to, so this is our A cross B. So in order for you to find the unit vector, so the unit vector will be, so we are just going to say, if this is the vector, the unit vector will be A cross B, then we are going to put the cap. This cap means to say it's a unit vector, which should be equal to the vector itself over the magnitude of that vector. So this is how we find the unit vector. So the principle is very simple. For example, if you have 1 plus 2 over, let's say 3, you will realize to say 1 plus 2 over 3 is the same as 3 over 3, which will give you a unit 1. So what am I trying to say? Imagine this addition 1 plus 2 is the vector itself. So if you get the vector itself over its magnitude, then you have a unit vector. Remember, a unit vector is a vector of just magnitude 1 or a unit of 1. So we can be able to say A cross B, we know that it is equal to 7i, then we have plus 2j, then we have minus 5k, then over the magnitude of A cross B. So the magnitude of A cross B, we found the magnitude to be the square root of 78, where when we did that, we found our square root of 78, which was this one. It's x squared plus y squared plus z squared. X was 7, 2, negative 5. We found the square root of 78. So since we have already found it, I really wanted to talk about that. So this is how you find the unit vector perpendicular to each vectors. Let's try another one. So let's say you have two vectors are given by A should be equal to 3i plus 2j, B is equal to this. Then they tell you find the vector perpendicular to both A and B. So remember, if this is your A, this is your B, then the vector that will be perpendicular to both A and B is this vector that will have 90 degrees there and 90 degrees in between, where here we can have any angle such as theta there. So how do you do that? So already find the vector perpendicular to both A and B means find the cross product. That's the meaning. So I'm just exposing you to the language. Now already if you look at your A, it's 3i plus 2j. Even B is 2i minus j. So what are we going to do with the j? Or with the z component? It means to say it's there. So this is the same as having A should be equal to 3i, then we have plus 2j, then we have plus 0k like that. Then we have our B, which should be equal to, our B should be equal to 2i minus j, then we have plus 0k. I haven't changed anything by introducing 0. The k is there, it's just that it's equal to 0. So to find the vector perpendicular, we are finding the cross product. So our A cross B should be equal to, we are going to do this. We put our I, we put our j, we put our k like that. Then the numbers again, we have our 3, 2, 0. Very important. We have our 2, negative 1, 0 again. So after doing that, we can be able to do the same math we were doing. So we begin by the first column like that. Then on top we do that. So where they meet, so we are going to be using plus, negative, plus. So we are going to have a positive I like that. Then write the numbers that are remaining. It is a 2, 0, negative 1, 0 like that. Then we have minus. We go to the second part. So let's go to our second. For our second row, we are going to remove this column, then after that we have minus our j like that, then do this. So already we are going to have a 3, 0, 2, 0 like that. Then finally we can be able to say plus. So we have plus, minus, plus. Looking at our last column, we can be able to cancel the last row and do this. So we are going to have the k where the two lines intercept. We have k, then we are going to have the remaining numbers are 3, 2. So we write our 3, 2, 2, negative 1 like that. Then from here find the determinant. So where we multiply this and this, so it will be I. Then times, we have 2 times 0, then we have minus our negative 1 times 0 like that. Then we have minus our j, do the same, 3 times 0, minus your 2 times 0 like that. Then we have plus your k. Then you are going to have your 3 times negative 1, 3 times negative 1, so this times this, minus 2 times this. So we have 2 times 2, like that. So we are going to have our I. Then to reduce things, we have 2 times 0 is 0, minus negative 1 times 0 is still 0. We close this. We have minus j, then we have 3 times 0 will give you 0, 2 times 0, we have still 0, then we are going to have plus k. Then on our k we are going to have our 3 times, we have our 3 times negative 1, it will give us negative 1, negative 3, then we have minus 4 like that. So this is what we have. So we are going to have our I times 0, this will be 0i. Then our j times the 0, it will give us negative 0j. Then we have minus, we have plus k. Then negative 3 minus 4 will give us negative 7 like that. So this will give us our 0i minus 0j, then negative times positive, it will be negative, then we have 7k like that. So this is our A cross B. So this is the vector that they are looking for, which is perpendicular to both A and B. So the cross product A cross B should be equal to negative 7k. Now let's say for the second part they ask you for the magnitude. So how do you find the magnitude? So the magnitude should be equal to, we have the magnitude, which is for the cross product for the, so the magnitude for the vector perpendicular to A and B. So how do you find that? So the magnitude of the vector perpendicular to both A and B is the cross product. So the magnitude will be, our A cross B should be equal to the magnitude, we put this, so it will be x squared plus y squared plus your z squared. So which will be equal to the square root of our x squared, which is 0 squared, because we only have the z component negative 7k. So we have plus, even our y is 0, then we have plus our negative 7, then we have a squared like that. So this gives us the square root of our 0 plus 0. Negative 7 squared will be plus 7. We are going to have our negative 7 squared will give us 49. So we are going to have the square root of 0 plus 0 plus 49. It will be 49. Square root of 49 will give you 7. So that is what we have. So let's determine the angle. Lastly, let's determine the angle between A and B. So remember, the angle between A and B is not equal to, is not unknown. So we have, let's say, this is what we have, our A, this is our B. The angle, this one is 90 degrees there. So this means to say we have our angle like that. So they want us to find the angle between A and B. It's either you can use the formula for the dot product, or you can use the formula for the cross product. Since we have begun with the cross product, let's use the cross product. So it shall be equal to, the magnitude of A cross B should be equal to the magnitude of the individuals A and the magnitude of B times the sine of theta. Now here they want the angle, they don't want the sine of the theta, they want the angle. So we know that A cross B, we have already found it. A cross B is equal to the magnitude of A cross B, we found A, 7. So let's just find the magnitude of A. So our A is equal to, first our A is equal to, we have our 3i, then we have plus 2j like that. Then we are going to say that our magnitude of A should be equal to the square root of our x squared plus y squared plus z squared, which should be equal to the square root of our x squared is 3 squared plus our y squared is 2 squared. Then we have plus our z is 0, okay? So we have a 0 squared like that. So after doing that, we can be able to say 3 squared is 9 plus 2 squared is 4. So the magnitude of A squared, when we find our A, our 9 plus 4, we are going to get a positive 13. Let's do the same for our B. So our B, we know that the vector for B, according to what we were given, it is equal to 2i minus j. So to find the vector B, the size of vector B, we can say that this should be equal to the square root of our x squared plus y squared plus our z squared. So which should be equal to the square root of our x squared, in this case will be 2 squared, plus our this one will be equal to negative 1 squared then we have plus our 0 squared, like that. So our 2 squared gives us a 4. Then we have plus negative 1 squared is a positive 1. So we are going to have the magnitude of b should be equal to the square root of 5, like that. So already we have found the magnitude of a is equal to the square root of 13. The magnitude of b should be equal to square root of 5, like that. So we have found that, and we know that our a cross of b, this one should be equal to, what did we find? So we found a value of a cross b is equal to positive 7. The magnitude of a cross b is equal to positive 7. So we can use this by saying that our a cross b should be equal to, we know that it should be equal to the magnitude of a times the magnitude of b times the sine of theta. So it shall be equal to, we have our a cross b should be equal to 7, which should be equal to the absolute value of our a is the square root of 13. Then we have times the square root of our b is equal to 5. Then we have the sine of our theta, like that. So when we multiply a 13 times 5, it will give us a 65. Then we have the sine of theta. So we can divide over the square root of 65 over the square root of 65. So that we have our sine of, we have 7 over the square root of 65 should be equal to the sine of theta, like that. So from here, we can take the sine this side. So we are going to get the sine inverse of 7 over the square root of 65. So upon doing that, we can be able to say this is equal to theta, like that. So we can say the value will be sine inverse of, so when we find the sine inverse of this, we're getting a 60.26 degrees. So this is our theta. So that is how you deal with the cross product. Thank you very much for watching the video. Hope you like, subscribe, and share for more. If you enjoyed the video, kindly like so that my video can reach a broader audience. See you in the next tutorial.